This video is about inverse trig functions. This is AP Precalculus topic 3.9. If you appreciate the content, please give it a like. For this concept, you need to memorize these 9 trig facts. So if you have not already done that, please pause the video and memorize this chart right now. You must also memorize the range restrictions for each inverse trig function. The value of arcsine can only be between negative pi over 2 and positive pi over 2. The value of arc cosine can only be between 0 and pi. And the value of arc tangent can only be between negative pi over 2 and positive pi over 2. I'm going to be showing steps for instructional purposes, but the goal is to be able to do all of this in your head. To evaluate arc tangent of 1, you should be thinking the tangent of what is equal to 1. The fact that the tangent of pi over 4 is 1 tells us that the reference angle is pi over 4. The reference angle is the angle between the terminal side and the x-axis. Between 0 and 2 pi, there are 4 angles with a reference angle of pi over 4. There's 1 in every quadrant. The tangent of any of these angles will either be positive 1 or negative 1. In this case, we want the tangent to equal positive 1. And we know that tangent is positive in quadrants 1 and 3, where the slope of the terminal side is positive. So that eliminates these 2 possibilities. The range restrictions of the inverse trig function will always leave us with only one possible value. In this case, arctangent is only allowed to be between negative pi over 2 and positive pi over 2. So that leaves us with only the first quadrant solution. The angle in the first quadrant that has a reference angle of pi over 4 is pi over 4 itself. To evaluate the arc cosine of negative 1, you ask yourself the cosine of what is negative 1. Cosine is the x value on the unit circle. Right here, the x value is 1. We are 1 to the right. Right here, the x value is 0. Right here, the x value is negative 1. And down here, the x value is 0. So, the cosine of this angle, which is pi, is equal to negative 1. Therefore, the arc cosine of negative 1 is pi. To evaluate the arc sine of negative 1, you ask yourself the sine of what angle is negative 1. Sine is the y value on the unit circle, and right here the y value is 0, here the y value is 1, here the y value is 0, and here the y value is negative 1. Normally we would say, okay, the sine of 3 pi over 2 is negative 1 because the y value here is negative 1. However, this takes us outside of the restricted range of arcsine. So instead of rotating in the counterclockwise direction like normal, we will have to rotate in the clockwise direction to stay within the restricted range. So instead of 3 pi over 2, we have negative pi over 2 because rotating in the clockwise direction is a negative angle. So the answer is negative pi over 2. By the way, inverse trig functions can be written in 2 different ways. They can either be written with a negative 1 superscript like this, or with the arc prefix. Either way, it's read arcsine, or arc cosine, or arc tangent, and both mean the same thing. To evaluate the arc tangent of 0, you ask yourself the tangent of what angle is equal to 0. Tangent is the slope of the terminal side. So at what angle is the slope of the terminal side going to be 0? A horizontal line has a slope of 0. So tangent will be 0 here at 0 radians and then again at pi radians. However, the range restriction for arctangent is negative pi over 2 to positive pi over 2. So we can only use 0 radians. So that's the answer. To evaluate the arc cosine of 0, you ask yourself the cosine of what angle is equal to 0. Cosine is the x value on the unit circle. and x values are equal to 0 here and here. Because of the restricted range of arc cosine, we will choose this angle, which is pi over 2. So the arc cosine of 0 is pi over 2. To evaluate the arc sine of radical 2 over 2, you ask yourself the sine of what angle is equal to radical 2 over 2. Because the sine of pi over 4 is radical 2 over 2, that tells us that the reference angle is pi over 4. There are 4 angles with a reference angle of pi over 4. There's one in every quadrant. However, because of the range restriction of arc sine, we will stick to quadrants 1 and quadrants 4. But then, because we want sine to equal positive radical 2 over 2, we will stick to the first quadrant where the y values, and thus the sine function, are positive. So, the angle in the first quadrant with a reference angle of pi over 4 is pi over 4 itself. So that is the arc sine. To evaluate the arc cosine of negative radical 3 over 2, you ask yourself the cosine of what angle is negative radical 3 over 2. We can determine the reference angle by ignoring the negative sign. Since the cosine of pi over 6 is radical 3 over 2, that is the reference angle. Within the restricted range of arc cosine, these are the two angles with a reference angle of pi over 6. Because we want cosine to equal negative radical 3 over 2, we choose the angle that's in the second quadrant where the x values, and thus cosine, are negative. We can think of pi as 6 pi over 6. Therefore, this angle will be pi over 6 less than 6 pi over 6, which is 5 pi over 6. So that's the answer. To evaluate the arctangent of negative radical 3, you ask yourself the tangent of what angle is negative radical 3. Since the tangent of pi over 3 is positive radical 3, that tells us that the reference angle is pi over 3. These are the two angles within the restricted range for arctangent that have a reference angle of pi over 3. Since we want the tangent of the angle to equal negative radical 3, we will choose the angle in the fourth quadrant where the slope, and thus the tangent, is negative. Be careful, the answer is not 5 pi over 3. 5 pi over 3 takes us well outside of the restricted range. It is bigger than the maximum value of pi over 2. Instead, we will rotate in the clockwise direction to remain within the restricted range. So the answer is negative pi over 3. You can evaluate the arctangent of negative 1 by asking yourself the tangent of what angle is equal to negative 1. We can find the reference angle by ignoring the negative sign. Since the tangent of pi over 4 is 1, the reference angle is pi over 4. Within the restricted range of arctangent, these are the two angles with a reference angle of pi over 4. Since we want the tangent to equal negative 1, we choose the angle in the fourth quadrant, where the slope, and thus the tangent, is negative. Be careful, we cannot use 7 pi over 4, because 7 pi over 4 is outside of the restricted range for arctangent. Instead, we go clockwise, so the answer is negative pi over 4. To evaluate the arcsine of negative radical 3 over 2, you ask yourself the sine of what angle is equal to negative radical 3 over 2. We can find the reference angle by ignoring the negative sign. Since the sine of pi over 3 is radical 3 over 2, the reference angle is pi over 3. These are the two angles within the restricted range for arcsine with a reference angle of pi over 3. Because we want sine to equal negative radical 3 over 2, we will choose the angle in the fourth quadrant, where sine is negative. We will not use the angle 5 pi over 3 because 5 pi over 3 is outside of the restricted range for arcsine. Instead, we will go clockwise, so the answer is negative pi over 3. To evaluate the arcsine of 0, you ask yourself the sine of what angle is equal to 0. Sine is the y value on the unit circle, and y values are equal to 0 here and here. Because of the range restrictions for arcsine, we have to go with this angle right here, which is 0 radians. So that's the answer. To evaluate the arctangent of radical 3 over 3, you ask yourself the tangent of what angle is radical 3 over 3. Since the tangent of pi over 6 is radical 3 over 3, we know that pi over 6 is the reference angle. Within the restricted range for arctangent, these are the two angles with a reference angle of pi over 6. In this case, we want tangent to be positive radical 3 over 3, so we go with the first quadrant. The angle in the first quadrant with a reference angle of pi over 6 is pi over 6 itself. So that's the answer. To evaluate the arc cosine of 1/2, you ask yourself the cosine of what angle is equal to 1/2. Since the cosine of pi over 3 is 1/2, that tells us that the reference angle is pi over 3. Within the restricted range for arc cosine, these are the two angles with a reference angle of pi over 3. Since in this case we want cosine to equal positive 1/2, we will go with the angle in the first quadrant. In the first quadrant, the angle with a reference angle of pi over 3 is pi over 3 itself. So that's the answer. To evaluate the arcsine of negative radical 2 over 2, you ask yourself the sine of what angle is equal to negative radical 2 over 2. We can find the reference angle by ignoring the negative sign. Since the sine of pi over 4 is radical 2 over 2, pi over 4 is the reference angle. Within the restricted range for arcsine, here are the two angles with a reference angle of pi over 4. Since in this case we want sine to equal negative radical 2 over 2, we choose the angle in the fourth quadrant where sine is negative. Be careful, we will not use the angle 7 pi over 4 because that takes us outside of the restricted range for arcsine. Instead, we will go clockwise and use the angle of negative pi over 4. To evaluate the arcsine of negative radical 2 over 2, you ask yourself the sine of what angle is equal to negative radical 2 over 2. You can find the reference angle by ignoring the negative sign. Since the sine of pi over 4 is radical 2 over 2, then pi over 4 is the reference angle. Within the restricted range for arcsine, these are the two angles with a reference angle of pi over 4. Since we want sine to equal negative radical 2 over 2, we will choose the angle in the fourth quadrant where sine is negative. We will not use 7 pi over 4, which takes us outside of the restricted range for arcsine. Instead, we will go clockwise and use negative pi over 4. The last 5 problems are multiple choice. To evaluate the arcsine of negative 1/2, you ask yourself the sine of what angle is equal to negative 1/2. You can find the reference angle by ignoring the negative sign. Since the sine of pi over 6 is 1/2, the reference angle is pi over 6. Within the restricted range for arcsine, these are the two angles with a reference angle of pi over 6. Since in this case we want the sine to equal negative 1/2, we choose the angle in the fourth quadrant where sine is negative. Be careful, we cannot use the angle 11 pi over 6 because this takes us outside of the restricted range for arcsine. Instead, we will go clockwise and use the angle negative pi over 6. So the answer is A. To evaluate the arctangent of 1, you ask yourself the tangent of what is equal to 1. Since the tangent of pi over 4 is equal to 1, the reference angle is pi over 4. Within the restricted range for arctangent, these are the two angles with a reference angle of pi over 4. Since we want the tangent to equal positive 1, we choose the angle in the first quadrant, where the slope and thus the tangent are positive. So the answer is pi over 4, the reference angle itself. So the answer is B. To evaluate a composite function, or a function inside of a function, work from the inside out. First, we will evaluate the sine of 5 pi over 3, which has a reference angle of pi over 3. Since the sine of pi over 3 is radical 3 over 2, the sine of 5 pi over 3 will either equal positive radical 3 over 2 or negative radical 3 over 2, depending on the quadrant. Looking at the reference angle, we can think of pi as 3 pi over 3. Doubling that, we can think of 2 pi as 6 pi over 3. Therefore, 5 pi over 3 lands right here in the fourth quadrant. Sine is the y value on the unit circle, and y values are negative in the fourth quadrant. So the sine of 5 pi over 3 is negative radical 3 over 2. Substituting negative radical 3 over 2 for the sine of 5 pi over 3 gives us the arc cosine of negative radical 3 over 2. We can evaluate the arc cosine of negative radical 3 over 2 by asking ourselves the cosine of what is equal to negative radical 3 over 2. We can find the reference angle by ignoring the negative sign. Since the cosine of pi over 6 is radical 3 over 2, the reference angle is pi over 6. Within the restricted range for arc cosine, these are the two angles with a reference angle of pi over 6. Since we want the cosine to equal negative radical 3 over 2, we choose the angle in the second quadrant, where the x values and thus the cosine will be negative. We can think of pi as 6 pi over 6. That makes this angle 5 pi over 6. So the answer is C. Number 19 is another composite function. However, if we try to evaluate this one from the inside out, like we did on the previous problem, we get stuck immediately. Normally, we would evaluate the arctangent of 2 pi over 3 by asking ourselves the tangent of what angle is equal to 2 pi over 3. However, the tangent of none of these angles is equal to 2 pi over 3. It's not one of our memorized facts. Instead of doing that, we will notice that we are taking the tangent of arctangent. Because these are inverse functions, they will cancel each other out, leaving behind simply 2 pi over 3. So the answer is C. On number 20, we do have the arc cosine of cosine. So these are inverse functions, so they will cancel each other out, sort of. We have to be careful because this time the outer function is an inverse trig function. So we have to worry about the range restrictions for arc cosine. For example, if we simply cancel out the arc cosine and the cosine, we get 5 pi over 4. 5 pi over 4 is outside of the limited range of arc cosine. 5 pi over 4 lands right here in the third quadrant, outside of the restricted range of arc cosine. On the previous problem, we were able to simply cancel out tangent and arctangent, leaving 2 pi over 3. This time, we cannot. So how do you know when you are allowed to cancel out a function and its inverse function, and when you can't? When you have a trig function and its inverse, if the regular function is the one on the outside, you can go ahead and cancel them out, because in this case, the outer function doesn't have any range restrictions that you have to worry about. On the other hand, if the outer function is the inverse trig function, you cannot simply cancel them out because we have to consider the range restrictions. Let's work from the inside out, starting with the cosine of 5 pi over 4. The reference angle is pi over 4. Since the cosine of pi over 4 is radical 2 over 2, the cosine of 5 pi over 4 will either be positive radical 2 over 2 or negative radical 2 over 2, depending on the quadrant. 5 pi over 4 lands in the third quadrant where cosine is negative. So the cosine of 5 pi over 4 is negative radical 2 over 2. Substituting this value in for the cosine of 5 pi over 4 gives us the arc cosine of negative radical 2 over 2. We can evaluate the arc cosine of negative radical 2 over 2 by asking ourselves the cosine of what is equal to negative radical 2 over 2. We already know that the reference angle is pi over 4 because of the inner function, and here are the two angles within the restricted range of arc cosine which have a reference angle of pi over 4. In this case, we want cosine to equal negative radical 2 over 2. So we choose the angle in the second quadrant where the cosine is negative. We can think of pi as 4 pi over 4. So this angle in the second quadrant is 3 pi over 4. So the answer is C. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.